All right, I got another video here that I want to go over. This is to help you with tonight's homework since we didn't have the opportunity to go over it in class fully. So it's a continuation of ratios, which is 7.1. This is dealing with rates. So I need for you to highlight a couple of pieces of information that are here. So we know that a ratio is a comparison of two quantities. Well, a rate just takes that and goes a little bit further. So on a rate here, I want you to have that it's a comparison by division of two quantities that have different units. And do me a favor, underline different units or box that, different units. That's very important. So in this case here, they're giving an example that a rate is you have Chris who drove 107 miles in 2 hours. So you're comparing miles to hours. So this is the rate right here, 107 miles in 2 hours. Down here, you got Shayna. She's at a grocery store. She's comparing two brands of juice. Brand A costs $3.84 for a 16-ounce bottle. And then you have brand B, which is $4.50 for a 25-ounce bottle. And if we want to compare the cost of these two rates, we actually want to try to find something that is called a unit rate. And a unit rate, which we've all done because you even did it on the test today, because you had to find out what's the better buy. That's kind of like what this is which one's the better buy? You have $3.84 for 16 ounces or you have $4.50 for 25 ounces. So remember, to go from a rate to a unit rate, so I'm kind of foreshadowing here, remember you divide. So we always also want to put money on top. So in this case, we would put the money on top. We'll put our ounces on the bottom. So we know it's $3.84 for 16 ounces. We do the same thing here. We know it is $4.50 for 25 ounces. Oh, let me write that up. 25 ounces. I put the 25 on bottom. I can divide to get a unit rate because unit means one. So I know it's $4.50 for 25. So how much is it for one? And I would need to divide. So that's what we're going to look at right here. That a unit rate is a rate in which the second quantity is one. So do me a favor, highlight that. Oops, sorry about that. Go ahead and highlight that. So unit rate is a rate in which the second quantity is 1 unit. And to do that, we are going to divide. So I just want you to write that in. So divide. This is nothing new. We've been doing this. So for example, Gerald pays $90 for 6 yoga classes. What is the cost per class? So this right here is your rate, $90 for 6 classes. I want to know how much it is for one class. So I would do 90 divided by 6. Put 90 on top. I always put the money on top because I want to know how much it is for one of something else. 6 goes into 9 one time. Bring down your 0. 6 goes into 35. So I am talking about right here that it is $15 per class. So this is your rate, and this right here is your unit rate. So I'm just going to put a UR next to it. For this one, here's just some of those your turns. So there's 156 players on 13 teams. How many players are on each team? So we would do 156 divided by 13. So you should pause the video and do that. All right, we are back. So I'm just going to do, for quickness purposes, I'm just going to do 156. I'm going to divide that by 13, and I get an answer of 12. Okay, well, that's not showing up, but we have 12 right there, so we know there are 12 players on the team. And it says a package of 36 photographs costs $18. What is the cost of photographs? So we want to know how much is it for one photograph. So I'm going to do 18 divided by 36. So I want to find out how many times 36 goes into 18. And that is going to be 50 cents. So it is 50 cents per photograph. Once again, just for time purposes, we're going to go ahead and do, and because it's hard to write just with your finger on the mouse, I'm going to do 18 divided by 36. So how many times does 36 go into 18? And there we are, 0.5. So that is 50 cents per photograph. All right, so now we're going to solve some problems using unit rates. So it says here you can solve rate problems by using a unit rate or by creating equivalent rates. So I want to highlight that if you would for me right here. So problem solving using unit rates, highlight that right there. You can solve rate problems by using a unit rate or creating equivalent rates. So here's just, I think the best way to do this is just to start with an example. So it says at a summer camp, the campers are divided into groups. Each group has 16 campers and 2 cabins. How many cabins are needed for 12 campers? Now, I'm going to eventually show you how to set up this problem using proportions, but I'm not going to do that right now. So this is what we know right here. So we know that we can have 16 campers and 2 cabins. So what I want to do is I want to take that rate and I want to make it into a unit rate. So that's the rate. And when we divide both the top and the bottom by 2, we get our unit rate. So here's what we know. We know that 8 campers fit in a cabin. So if we know that 8 campers fit in 1 cabin, we want to know how many cabins we need if we have 112. So here's where we're going to divide right now. So we take our 112, we divide by 8. So 112 campers, 8 for every 8 campers, it's a cabin. And when you do 112 divided by 14 or divided by 8, you get 14 cabins. Now, there's another way that I could have done that is I could have done a proportion, which we'll get to. But a second method right here, which I really like too, is you put what you know on the right. So this is the known information. And this is getting into kind of like the proportions. And proportions just show that 2 ratios are equivalent to each other, is what it is. So I have my ratio of 16 campers is 2 cabins right here. So this information came right there. And if campers, it's imperative that you put the unit that you label. So 16 campers. Campers goes on top. Therefore, campers has to go on top over here. So 16 campers. I need to get to 112, 2 cabins. Now, originally this was X. This was unknown. So 16 times 7 is 112. Or you could have said, hey, what's 112 divided by 16? 7. But remember, if I multiply this way, I can multiply this way. And that is how we come up with the answer here of 14. So either way works. I love this way right here because it actually gets into proportions and where we cross multiply and then create equations and divide both sides by the number in front of the variable, by the coefficient. So both ways are great. If you want to choose one way, or I'd go this route. So okay, here's some your turns. So Petra jogs 3 miles in 27 minutes. At this rate, how long will it take her to jog 5 miles? So once again, we know that 3 miles, I'm going to try to write this. 3 miles take her 27 minutes. And I want to see how long it takes her to go 5 miles. So I'll put my X on the bottom. Sorry about that. Okay, so if I can do 3 going into 5, I will, but 3 doesn't go into 5 evenly. So I'm going to try to reduce this, and I can reduce the 3 over 27, and 3 goes into 3 1 time, and 3 goes into 27 9 times. So basically every mile takes me 9 minutes. So I run a 9-minute mile, which isn't bad. So I can do 1 times 5 to get 5. So now I'm going to do 9 times 5, and you get your answer of, what is it? 45 minutes. So I can run 5 miles in 45 minutes. So that's one way to do it. There's another your turn here. When Jerry drives 100 miles on the highway, his car uses 4 gallons of gasoline. How much gasoline does he use in 275 miles? So once again, you can set that up the same way. See if you can reduce and multiply across or divide across. And that should help you. Here's some more guided practice. And then that should help you also with the independent practice. So I hope that helps.